Today we're going to talk about 2021 Fall AMC 10A P15. Isosceles triangle ABC has AB equals AC equals 3 root 6, and a circle of radius 5 root 2 is tangent to line AB at B and to line AC at C. What is the area of the circle that passes through vertices A, B, and C? So basically, for the area of the circle that passes through vertices A, B, and C, we call the circle O2, so it has center O2, and we let the radius be R. We know this, we call the circle with radius 5 root 2 O1, and we let it have a center of O1, so it's tangent to AC and also BC at B and C. So basically here, firstly, we have two approaches. One is an approach that I figured out, but it's really complicated and it's really time-consuming. And the second is a really simple approach. So let's talk about the simple approach first, since you lot probably watched this video for your AMC exams. So, firstly, if O1C is tangent, so if O1C is a radius, and the circle O1 is tangent to line AC, this angle here, O1CA, is 90 degrees. This angle here, O1BA, is also 90 degrees because of the tangent. So now we have two 90 degrees, and also we're going to introduce two new lines to the graph. So I'm going to add this line, which is a perpendicular line. I'm going to add this line, which is also a perpendicular line. I'm going to say that this point is, so this point is D, and this point is E. So what's special about these two lines? Well, firstly, the circle that is tangent to A, that passes through vertices A, B, and C for triangle ABC, is the circumcircle. So O1 is a circumcircle. And what's special about a circumcircle? So you should have learned this, but if you haven't, I'm going to say it now. So the circumcircle is basically where all the perpendicular bisectors of each side meet. So the O2 is where all the perpendicular bisectors, like this one and this one, like the perpendicular bisectors all meet at this point, so it's the center of the circumcircle. So basically this means that if I had O2E, then this would be a perpendicular bisector of line AB. So these two sides are equal, and these two sides are equal. And basically from this we can have a similar triangle, so similar triangles, and this occurs when we extend AO2 until it meets O1. So the reason O1, O2, and A are all on the same line is also because of the circumcircle. So we have this chord here, and AO2, so it's actually a side BC of the triangle. So O2, whatever this point is, let's call it F, bisects, is a perpendicular bisector of BC, so this is a 90 degree. And O1 to F, O1F is also a perpendicular bisector because it also bisects the sides. It also bisects the side BC. So we know that the 3 points are the same line. So we can draw this and we can call this a triangle. So firstly, let's highlight the triangle that we want to call similar out. So one is O1CA, and the second one is, so let me do this in another color. In purple. So the second one is O2D and A. So I claim that triangle O2 D and A is similar to triangle O1 C and A. So these two triangles are similar, and that is actually true, but why? So firstly, we have AD over AC is 1/2, because we know that from the circle thing, O2D is a perpendicular bisector of side AC. So AD is half of AC. Now secondly, we actually don't need this, so we can use angle similarity proof. So firstly, we have angle CAO2, we have angle CAO1 equals angle DAO2. Essentially, it's the same angle, so CAO1 is equal to angle DAO2. That's really obvious, it's obviously true. An angle equals itself, that's true. And secondly, we also have, so since O1C is perpendicular, let me just write that, since O1C is perpendicular to AC, and we also have O2D is perpendicular to AC. So basically, if these two angles are equal, we get that these two angles are equal, right? We have angle O1CA equals angle O2DA. So because 90 degrees equals 90 degrees. So now we have one, and we have two. We have two angles that are equal. We can use AA to prove that our triangles are similar. So what's the point of actually proving similar triangles? So the point is we can use the ratio to figure out O1A. We can use the ratio, to figure out O2A. So what is O2A? So why do we want to figure out O2A so badly that we created similar triangles? O2A, if you look at it carefully, it's the radius of circle with center O2. So O2A is actually the radius. And we're trying to figure out this area of circle O2. So we have the radius, the area is like pi r squared, right? And we know that O2D bisects AC. So we have DA over CA is 1/2. And since the triangles are similar, we have this ratio apply for every corresponding side. So we also have O1A. So we also have O2A over O1A, which is 1/2, because this is a triangle. This is one triangle. This is another. The two sides are corresponding, so O2A over O1A is also 1/2, and we know O1A, so we can obviously figure out O2A. So what's O1A? If we look at this carefully, we have a right triangle here, which we know the legs of, so we can figure out the hypotenuse using the Pythagorean theorem. So O1A is gonna be 3 root 6 squared, so 3 squared is 9, root 6 squared is 6, so that's going to be 54, plus 5 root 2 squared is 50, so we have root 94. If we know that O1A is root 94, we have O2A equals root 94 over 2. So we already have the radius, so the rest is just applying the circle formula, the area formula. So pi r squared would give us pi times 94 over 4. If we simplify the fraction, we have 47 over 2 pi. wait, sorry. This part is not 94 pi, it's 104 pi. So I made a mistake here. So this gives us 2 root 26, and so we can just change this whole thing. This is why it's important to check your working. I wasn't aware of that, so sorry. But okay, so O2A is gonna be root 26. So if we have this, then we have the pi r squared to be pi r squared. R is root 26. Root 26 squared is 26. We have pi r squared, the area, to be 26 pi. So we're going to choose C for our answer, and this also demonstrates it's important to check our calculations to avoid simple but yet crucial mistakes like the one I just made. So thanks for watching. I hope you learned something about circles, tangents, and also similar triangles and how they can be used in the same problem. Thanks and bye.